Hey folks, want to talk just a little bit today about logical appeals. This is the logos aspect of the rhetorical appeals. So let's go ahead and get into this. All right, so ultimately there are sort of two branches of logic that we will consider in our class. You talk to philosophers, you talk to mathematicians, there are lots of other types of logic, but this is what we're going to look at: deductive and inductive. We're going to take a look at deductive first. The idea behind deductive logic is that you take a rule and then you apply it to a situation. If we know something is always true, we can then apply it to the situation. The main type of deductive reasoning is syllogistic logic. This is the argument that if two related premises are true, a related conclusion must also be true. This seems a little confusing right now, but once you see the example, it will make perfect sense. The mathematical idea behind this is, very basically, if A equals B and if B equals C, then A must also equal C. Mathematically, that's very easy to understand. Alright, don't read into my politics here. I am not making an argument for or against abortion, and my purpose here isn't actually to discuss that, but it is to discuss the logic that goes in here. A great example of syllogistic logic is the argument for why abortion is wrong. Murder is killing a life, and a fetus is a life. If we accept those two premises, we must accept that abortion is murder, and as a result, abortion is a bad thing. Okay. That's the way syllogistic logic works. If we can accept the premises, and it's very clear that those premises are inherently related to each other, we must accept the conclusion. Of course, if your audience doesn't accept the premise, and this is where people who are pro-life and pro-choice disagree on the issue of abortion, that becomes problematic. Those folks disagree on when a human life begins. It's that premise of a fetus is a life that they disagree upon, which is why they disagree upon the conclusion. Okay, but that's the way syllogistic logic works. It's really great if you can make this case and your premises are airtight. If your premises are airtight, your conclusion will be airtight and you can make a really solid argument. If not, you'll have some problems. Okay, the other half of this chart is focused on inductive reasoning. We'll take a look at that next. All right, inductive reasoning is taking a situation and developing a rule from it that you can then apply to other situations. I always say this is how babies learn. If anyone's got children, many of you do, I can see from your introduction. So if you ever watched a kid throw a fork on the floor, they see that it falls and hits the floor. They do it again, they do it again, they do it again, and then they realize, of course, that this can be, A, very fun, because their parents will continually bend over and pick up the fork, but that they can put any other object that they have, shove it off a table, and it will hit the floor. Frankly, I suppose if you have cats, you'll see something similar. Now, there are some different types of inductive logic, and the first one of those is analogical logic. And now, if you remember back to your SAT or ACT, the word analogy, this is the argument that two similar situations will yield similar results. I'll give you a nice example here. So after past economic downturns, the economy recovered at a rapid rate. So it's likely that we'll see similar growth once this downturn ends. The two similar situations are the economic downturns. We're presuming that we'll see similar results from this. Okay. The next kind of inductive reasoning is categorical. Okay, this is the argument that situations in the same category will yield similar results. So it's slightly different, but it should work more or less the same way. Scandinavians have a higher than normal rate of celiac disease, so all Danish medical patients with symptoms should be tested. This is actually how a lot of medical work gets done. If we know a certain population has a higher rate of something, when someone comes in with those symptoms and is from that background, it makes a lot more sense to test them than someone from maybe another background who that category of people has very low rates of this disease. Okay, so this is a great example of why we should test certain people and not others. And finally, in inductive reasoning, statistical logic. This is the argument that if a sample of a population does something, the whole population will likely do it at the same rate. We see this all the time in research. Very rarely can anyone research an entire population. They choose a sample, they run a test with them, they extrapolate that test out to the population. So here we go. Our study showed that 10% of surveyed married men cheat on their wives. We can presume that 10% of all married men cheat. Okay, this is extrapolating from a sample size to a larger population. This is something really to look for in your research papers, and ultimately, as you guys are working on finding articles for your papers, just how big is that sample size and what does that tell us? That's something we'll talk about later on in the semester. So there you have it. These are all the different types of logic, deductive and inductive, and the different versions of those. Make sure you know those 4 different kinds: syllogistic, analogical, categorical, and statistical, because we're going to be working some more with those this week. As always, if you have any questions, do not hesitate to let me know.